Hello, Calculus 2 students. I'm going to go over 3 problems where we calculate distance traveled, where we have motion in space. The hard part of these problems is simplifying the speed before we start integrating. So we have 3 different types of examples here. They were wonderful for us. We will get started with number 1. We are given position. This is in R3, and we want to calculate the total distance from t equals 0 to t equals 1. Through all of these, the directions say give an exact answer. Well, step 1, we calculate velocity. To get the velocity, we just differentiate the position function. So when we take the derivative of the first coordinate, we get t to the 5th. The derivative of the second coordinate, you notice we get minus 3t cubed. The derivative of the third coordinate, we have t cubed. This is the velocity. Velocity is a vector. Now speed, this is the length of the velocity vector. How we calculate the length of a vector in R3 is we take the square root, and then we square each coordinate. So this would be t to the 5th squared. This would be minus 3t cubed squared. And then we have plus t cubed squared. Okay, what are each one of these? Well, you notice we have power to a power. Power to a power, we multiply. So here we have t to the 10th power, and then we have a 9, t to the 6th power plus t to the 6th power. What can we factor out of every single term? Well, I can factor out t to the 6th, t to the 6th, and then we have times, this will be t to the 4th, and then I have plus 9 plus 1, which is plus 10. The good news is that I can take one more step here. So t ranges from 0 to 1. And so if I take the square root of t to the 6th and t is positive, I just get t cubed. So I have t cubed times the square root. We have t to the 4th plus 10. This is something I can integrate. So I have simplified this as much as I need to here. At this point, I'm ready to write down my integral. So the distance traveled, we integrate 0 to 1 of the speed, which is the length of the velocity vector. We have already calculated and simplified this. So this is integral 0 to 1 of t cubed times the square root of t to the 4th plus 10. T to the 4th plus 10. We can integrate this by substitution because we see this inside function. We see multiple of its derivative in the integrand. So let's write the work for substitution here. My u, this is t to the 4th plus 10. du, well, we take the derivative, 4t cubed dt. So you notice we have t cubed dt. This will be 1 over 4 du. Now, people who know me know I changed my limits of integration to u limits of integration. So you notice t ranges from 0 to 1. When t is 0, u is 10. And when t is 1, u is 11. I have an integral from 10 to 11 of u to the 1/2 times 1 over 4 du. I'm ready to integrate. So I have the 1/4 is the constant. When I add a power and divide by the higher power, I have u to the 3/2 times 2/3. And then we evaluate between 10 and 11. So the constant out in front here is 1/6. And then I have 11 to the 3/2 minus 10 to the 3/2. This is exact, but we leave it like this based on the directions. So this is the total distance traveled of this particle from t equals 0 to t equals 1. The strategy in this one, I will say, we factored out what was common to every single term here, and this allowed us to realize we could integrate using substitution. So let's do the next one, number 2. Okay, once again, we're starting with position. Let's calculate velocity. Well, Derivative of the first coordinate, you notice I'd have negative 2t to the 1/2. Derivative of the second coordinate is 2, and the derivative of the third coordinate is 0. Now calculate the length of the velocity vector. This is a square root. We have minus 2t to the 1/2 squared plus 2 squared, and then 0 squared. What do we have here? You notice I have 4t plus 4. So this is not too bad to simplify. I can even take one more step, really, because if we factor out a 4, the square root of 4 is 2. So here I have 2 times the square root of t plus 1. Now we can integrate 0 to 3 of 2 times the square root of t plus 1. This is one you notice, okay, technically substitution, but my inside function has derivative 1. So personally, I would just integrate this. Write down the 2, and then we add a power, and then we divide by the higher power, like this, evaluated between 0 and 3. We have 4 over 3, and then we have 4 to the 3/2 power minus 1 to the 3/2 power. But both of these we can evaluate. We have 4 over 3. This here, it says take the square root of 4 and then cube it. Square root of 4 is 2. So we cube it, we get 8. So 4 over 3, 8 minus 1. So this is 7 times 4 over 3, 28 over 3. This is exact. This is how we leave our answer. Next question. Okay, we see cosine 1 over t, sine 1 over t, and square root 3 over t. Once again, we are given position. Once again, we want to calculate distance traveled. Give an exact answer. Well, let's calculate velocity. We have to be a little bit careful this time because to calculate the velocity, to differentiate cosine of 1 over t or sine 1 over t, chain rule. So let's do this here. This will be minus sine of 1 over t. Now multiply by the derivative of the inside function, which is negative 1 divided by t squared, comma. We have cosine of 1 over t multiplied by the derivative of the inside function, which is, once again, negative 1 over t squared. And then, comma, finally, we have the constant, which is square root of 3. And then we have minus 1 over t squared, like this, where if you want to write it, the derivative of t to the minus 1, that's what I use 3 times. We have minus t to the minus 2, right? This is what I have used here. The length of this vector. First of all, you notice this first one's positive, but let's just start writing things down. Sine 1 over t squared. Quantity squared, okay, plus the second coordinate, we have a minus cosine 1 over t. And then we have 1 over t squared, and then plus the third coordinate, which is, well, it's negative square root 3 over t squared. We can definitely do some work here. So here you notice I get sine squared 1 over t, and then I have times 1 over t to the 4th, plus I have cosine squared 1 over t, and then times 1 over t to the 4th, plus, well, square root of 3 squared is 3, so I just have positive 3 over t to the 4th. Okay, this is actually starting to look really wonderful because sine squared plus cosine squared is 1. It's the most important trig identity. So maybe I'll take a step here and factor that out. We have 1 over t to the 4th. We have sine squared of something plus cosine squared of the same thing. And then I have this 3 over t to the 4th. Now, with this parentheses, this part, sine squared plus cosine squared, this is 1. So look what we're left with. inside is the square of something. This will simplify very nicely. I have the square root of 4 over t to the 4th. This is just 2 divided by t squared. All of that work, but the speed is 2 over t squared. This is a wonderful function to integrate. Okay, let's do this now. We integrate 1 to 3 of the speed dt. This would be the integral 1 to 3. I'll write it this way, 2t to the minus 2 dt. We can use power rule. This would be, well, it's 2t to the minus 1 over minus 1. And then we evaluate between 1 and 3. So I have negative 2 over 3. And then minus and minus becomes plus. So this is plus 2. So let's see. 2 is 6 over 3. Altogether, I am left with 4 over 3. But you notice the hard part in this one. It was not the integration. The hard part was simplifying the speed, and quite often this is the case. So I hope these problems were helpful for you. Thank you so much, students.